Hi everyone and welcome to today's level up video. My name is David McGreene and I'm the course leader here at ACM for the Games Development degree. And today we're going to be making a very fun project. So it's going to be a hybrid between a mini golf game and a rollerball game, utilizing Unity and its physics. Just a point I just want to mention before we get started. So for anyone who's new to Unity or possibly scripting as well, is just to have a look at some of our prior content for Level Up as well. So we had Huda, one of our programming tutors last week, cover programming. So if it helps to build up a bit more understanding of some of the things we'll be looking at today, if you've not had any prior experience, I really recommend to check out those videos as well. And also before we get started, I'm just going to showcase what the end result will look like. But I'd say today will be really interesting, especially for those of you who are interested in game design, who like creating your own levels, maps, because this is quite a modular project. It will allow you to come up with lots of variations without having to change too much. So for those of you who have come up with some really great ideas and levels you want to show off, it'd be great if you could send those in and we could have a look at those. But just to show you how this project works, you have a controllable playable where you can move forwards, backwards, left and right, with the addition of jump as well in case you've got any obstacles or any gaps that you can see on screen. So I'm just going to cheat for the time being. And one of the other mechanics that we're going to include today is additional forces being added to the ball. So if there's anything like a jump pad, a launch pad, or even a ramp, you can actually launch your ball into any direction of choosing. So you can create, again, some really interesting ideas for your level and not have them all attached to one another. You can actually create islands, for example, and have the ball launch from one to another. But as I go underneath this windmill, you can see that in action. It's very subtle, but again, you can change the direction, the force, and create some really interesting ideas for your game levels. And the whole idea is just to avoid all the obstacles and get to the final endpoint. And that's a very simple level, but all the possibilities are endless. You can come up with so many cool ideas, and again, it'd be great to see all of those. So let's get started in making this. So I've already opened Unity prior to this. So for anyone who is opening Unity, one thing I just recommend is to hit that 3D option. So when you open Unity and Unity Hub, go to create a new project. Make sure you hit that 3D option just so it saves you a few seconds. It's not a major problem, it'll just be the camera angles that are slightly different, but just make sure you do hit that 3D option just to save yourself some time. Cool. The next point we want to start with is importing some assets. So you saw already we had some visual assets that I used to create the level, and I can show you where to grab those, and I'll put the link in this video as well. But I use this website called Kenny, and he has lots of great assets for lots of different genres of games, so I recommend checking that out as well. But I use this particular asset pack called the Mini Golf Kit. So I've already downloaded this. I've already downloaded this onto my computer. I've got this onto my desktop over here, and it's in a zip folder. So what I am just going to do is I'm just going to open this zip folder, and I'm just going to drag one of the folders out that includes all of the models. So the one I want is this FBX folder here called FBX format. So I'm just going to drag that to my desktop. So I've already done this prior to this video, so you can ignore that step there. But once you drag that into a location of your choosing, then you can bring it into Unity. So we're just going to import all of those files so we can begin to use them for this project. So it takes a few seconds, but it shouldn't take too long. Once that's all done, if we have a look inside of that folder, we can see all of those assets there. So I think a starting point is let's add the end model to our scene. So you can see it's just a starting point and somewhere that we can begin to create our level. So if I go to my scene view and just drag this in, so if I just drag that in here, I don't quite know where the X and Y Z is because it can be anywhere. So one of the best things I recommend is just drag it in your hierarchy, and it will end up at 0, 0, 0, just so it makes it a bit easier to move around and see. So we have our starting point of our level, it's just the beginning point, just so we can see what we're working with. The next point is let's also add our ball. So I'm going to use the red ball just because we've got the green for the grass or the ground for our level tiles. And I'm going to again drag that into my hierarchy, and I'm just going to move that up slightly just so we can see it. I'm also just going to rename that just so I can see what I'm doing and what I'm selecting. And there we go. So I'm just going to move my camera for a moment, and I'm going to hit play, and you're going to notice straight away nothing's going to happen. It's just static. These are just two items that stay still. So one of the first points we want to get working is the physics. We want to have the physics working. So one, gravity is applied, and two, we can begin to move our ball around our scene. In order to do that, we first need to add a component to enable physics on our player ball. So if we select our player ball, and then if we look on the right hand side of our screen in the inspector view, we can see that we have a number of components, but the one that we want to add is what's called a rigid body. So this enables physics on game objects. If we hit this button down below called add component and start typing in rigid body, we can see we have two options available. So we've got rigid body and rigid body 2D. So the one that we are looking for is rigid body. Rigid body 2D, as it sounds, is for 2D game objects, but we want to have the 3D object, the 3D option. So if we just want to select that, you can hit enter or you can double click, and it will then add to your game object. And if I was to hit play now, you'll notice that the ball will start to move, so gravity is being applied, but it's ignoring that ground there. It's just going completely through it and acting like it doesn't exist. Reason for that is it doesn't have a collider. It doesn't know what the boundary is for not only itself, but also the other game objects. So it doesn't know where that intersection will occur to stop the ball from going through. So the way that we can stop that is first, with the ball still selected, we can add a collider. So if you start typing in collider, we have a number of options available again, but ignore those 2D options. Let's just look at those ones that don't have the 2D option or tag at the end. And because this is a sphere or a ball, we can look at just using the sphere collider. So as I select this, you'll notice, or whether it be in the video or on your own screen, you can see a green sphere that's now around our mesh or our ball. This just represents this is the boundary, this is the collider to now detect any other colliders on any other mesh or game object in our scene. So we have our ball sorted out now, and now we just need to add it to this end tile piece of the level. I'm going to use a different collider for this one. I am going to use what's called the mesh collider. This is just because it will take into account how the mesh is built up, so taking into account its polygons and faces. So if I was to hit play now, you'll actually see our ball now take into account there's something there. It stops in its track and it's no longer falling in the empty void infinitely. So we have our starting point. So we've got our ball with physics enabled, and now it can detect when it's on a piece of the level. So the next point we want to start with now is actually moving our ball around the scene. So being able to control our ball. So we can do that by adding a script. I've already created one, but I'm just going to delete that and do one from scratch. So in order to add a script to a game object, all we need to do is select the object we want to add a script to. Similar to before, hit the add component button, and I'm going to type in player. Now because there isn't a component called player, we have the additional option to select a new script, and this will just give you a confirmation of what you want to call your script. So in this case, I would like to call it player, and I'm just going to confirm that by hitting create and add, and it will take a few seconds and it will add that for you. So you can see the compiler and also that pop-up on your screen. My computer's quite slow, so yours might be slightly faster at home. So you can see now that the script has been added to that game object. So if I was to double click that, it will now open up the script editor that you have installed. Primarily it's going to be Visual Studio, and then we can begin adding some scripting to that. So not too much scripting, but just enough to get what we need working. So we have our rigid body, and this is what we're going to use to manipulate how we control the ball. So we're going to add forces depending on what direction our player is trying to get to or input in. So first point we need to add is a variable to communicate to that rigid body. So I'm going to add a variable, a public variable called public rigid body, and we're going to give it a variable name of RB. And once that's done, if you hit save, if you just want to make sure that's working, if you go back to your Unity project and select your playable, you'll see that that variable that we just created will now be visible in the inspector. So we can see it here, and if we want to drag that in, we can do that already, or we can also hit that circle and we see the available options. Since there's only one rigid body in the scene, there's only one option available, so we can just hit that and we've got that confirmed. Now that we have our rigid body linked in, so our script can communicate with that, we can begin to add forces from our player controls. So what we want to do is we want to go to our update. So our update is where our game is running every single frame. We can begin to communicate with our playable on a frame by frame basis. So let's begin to add some input. So what we want to say is we want to get input from the player, and then based on what direction they're moving in, apply that to the physics or the rigid body attached to the ball. So we've already created that variable called RB, and we want to start to add force to that. Now, when we're adding force, it has to take into account what direction or how much on each axis it's going to go and head towards. So if we were to think of an explosion underneath the ball, that would go in a particular direction of up. And that will be what's called the y-axis. So we have x, y, and z. So x being horizontal, y being vertical, up and down, and then z being backwards and forwards, so the depth. With our input scheme, we want to be able to go left and right, so that would be the horizontal axis. Then we want to go backwards and forwards. That would not be the y-axis, that's up and down. We want to go backwards and forwards, which would be the z-axis, the depth. So we want to create a new vector, x, y, and z, just so we can make sure that we're moving our ball in the correct direction. So if we start typing in add force, and the direction of this force is going to be a new vector 3. And inside of this, if I just put a 0 and a comma for now, you can see that we can actually add all of the axes or axis values, so x, y, and z. So we know, first of all, if we want to move left and right, that will be for our first value we enter on the x-axis. So that can be either the A key or the left arrow going left, or the D key and the right arrow to go right, so horizontal. We can actually get that value from Unity. Unity has that all pre-set up for us, and the way to do that is if we say input dot get axis, and inside of that we just type in horizontal. Unity will pass a number between -1 and 1 to show what direction we are going in terms of the x-axis. So either left being -1 or 1 being right. So if it's 0, that means it's not moving, and then -1 being left, and then positive 1 being right. So that's for our ball going to left and right. So this is going to add force to our ball going on the x-axis left and right. For the next one, for the y-axis, this is not what we need for now. We don't want to control it going up and down just yet, so we're going to leave that as a 0. And then the final point is the z-axis, so going backwards and forwards. So I'm just going to copy this for a second, and I'm going to type, instead of horizontal, this time it's going to be vertical. So this is going to be the W or S key or the up and down arrow. So Unity will pick up on those values and tell us is it a positive or negative, so negative being backwards, or positive being 1 represents going forward. If it's 0, it means there's no input at that moment. So now we have our input. We can just close it off, so I just missed one of those parentheses, and then I can save that. So this is now going to talk to our rigid body and then begin to apply a movement based on what we are pressing. So if I just save that and head to Unity and hit play, so this may be very slow, but we can start to see force being applied based on what key you have pressed. So if I hit the W key, you can see it's moving forwards. If you hit the S key, it's going backwards. A, left, and then D is going right. So the camera angle isn't correct, but if we look at that ball, so you remember when I mentioned the X, Y, and Z axis, Unity has these gizmos that represents that. So we can see that the green arrow that represents the y-axis, the red arrow represents the x-axis, and the blue arrow represents the z-axis. So it shows what direction they're heading in. So if I was to actually move my camera to look in this perspective and use my controls again, we can see that it goes forwards, it goes backwards, it goes left, and it goes right. So you probably can't see the keys that I'm pressing, but I'm moving in a direction that I'm expecting because of the camera perspective. So if your ball isn't moving in the correct direction, if you select it, just make sure that the forward axis, so the z-axis or the blue arrow, is facing that way, going straight ahead, and then the red arrow is facing right, and then the green arrow is facing up. So if your ball isn't moving in the correct direction, just make sure those arrows are in the correct direction. Okay, so the next point is adding some speed. So we may want to speed this up just slightly. So what we can do is we can add a public float, and we can call this speed. And for now, let's just add a value of 5. And at the end of our add force values, we can actually multiply this. So we can say perhaps we just want to multiply it by the value of our speed variable, and that will increase how quickly our ball will move around. So again, just to quickly preview that, if I was to hit play, we can now see my ball moves a lot quicker now compared to before. So the reason why that's also useful is because we can adjust that. So we can actually adjust that here. So if you feel like it's a bit too fast, then you've created this level where it needs a bit more intricate control, you can adjust that speed. So perhaps you can lower it. So let's say 3, for example. And if I hit play again, you can see, so it's a bit more slow. So you can adjust that value as needed, but I'm just going to set that back to around 1. And that will do for now. Okay, so the next point that we can work on is let's add the ability to jump. So let's have the ability to jump with our ball. So we're going to need a boolean to detect if we are on the ground or not. So let's add a public boolean, and we're going to call it grounded, and for now we're going to set it to be false. And we also want to use a function. So if, again, for anyone who's not had much experience with colliders, there's events that get triggered when physics occur. So one of the things that we can do is we can say when our ball collides with another collider, we can actually get that event information and use it to our advantage. So we could say if our ball touches the floor, for example, we know that our ball is now on the ground, meaning that you can jump. And this is how we can stop the player from continuously jumping without any restriction. So what we want to do is we want to say on collision enter, we can say grounded, the boolean variable we just created, is going to be equals to true. So this just means when the ball touches an object with a collider on, it's going to detect that, and then we're going to set this boolean called grounded to be true, just to mean that we can actually know that our player or our ball is on the ground. So the next point is adding that force to make it jump upwards. So let's also say let's use the space key. Let's use the space key to make our player jump. So we're going to type in an if statement, and we want to say if our input dot get key down is going to be the space key, then we want to add some force. So for now, let's just use a single value, but let's say I think how much? Let's use like a value of like 50 or so for now. So what we can type in, we can use a vector3, and instead of typing this up manually, we can just say vector3.up, which just represents 0, 1 for the up axis, the y axis, and then 0. So it's a short way of typing it out. And then I'm going to multiply that by, let's say, 50 for now. So it might be worth creating a variable, but just so we can test it, we can see. So to stop that continuous jumping, what we can also say is once we've added that additional force, we are then no longer grounded, and we have to wait for our ball to come back down and collide with something in order to jump again. So I'm just going to hit save, and then let's hit play to try that out. So we can see our ball moves around. Now if I hit the space key, we can see it jumps, but it's a very low value. So instead of 50, I'm going to jump that to 250. Now, because it's a bit time consuming to go back and change, what we can also do, we can actually create a variable, so we can just use our inspector to change its value just like we have for the speed. So you can see that's actually very high, and that's a bit too much. So let's add a public float, and let's say jump force, and I'm going to set that to be 100 for now. And there we go. So now instead of having to go back in the code, we can just constantly go in our inspector and adjust that value as we deem fit. So I'm going to test that one more time. Hit the space key. Yep, there we go. So you may want to change that value. I'm just going to leave that as 100 for now. We can change it as needed. But we can see we've got some functionality working already where we can control the ball, we can move it around. We can tell when our player is on the ground, when it's colliding with an object that has a collider, and also we can jump as well. So we have some of the basics to get our game started. I'm just going to rotate this game object around just so we can know that this is the direction that we're going in. And there we go. So I'm going to add one more piece as well, just so we have a little bit of level to go over. So let me just minimize that. Let's find an interesting piece to use. Let's use this one just for now. So I'm gonna drag it in. Wait, actually not that one. It's only that doesn't have any bumps on for a flat surface. Let's just use this one for now. Okay, so it's called open. I'm gonna just snap it in front so we can just put it there. So we just have a little bit of a run up or a bit more space to move around. And again, any new piece that you bring in, you need to just add a collider on. So I'm gonna add a mesh collider, attach it to the game object, and now our ball will be able to walk over without falling through, as you can see. There we go. Right, so the next thing we want to add is the idea of being able to go into an area where force can then be applied in any direction. So what we can do is I'm going to create a new game object, and I'm going to call this force zone. And I'm also going to give this a gizmo icon just so I can see it. And we can see that it has this little icon now in our Unity scene. I'm actually going to change that to grey and move it over here. So what we can do is we're just going to create another script, but it's going to be a very simple script, and I'm going to call this script force zone, and I'm going to attach it to this game object. So I'm also just going to remove that space in the name once this is done. There we go. So I'm going to open the script, and what we want to add here is we don't even need any of this. Just a variable for a type of vector free, and this will allow us to put in how much force should be applied to the ball should we go in an area of our level. And this is where we can start to do things like jump pads, ramps, all sorts of ideas that you may want to come up with. So if we're typing public vector free and name this force, and then just give it that space. There we go. So not much going on in script, but we have a value that we can put in. So what I'm going to add just to showcase how this works, if I put so if we look at this variable here, so we have an X, Y, and Z. So again, if we look at these gizmos in the scene when you select an object, you can see these arrows. This shows you what axis they're facing or what way they're heading. So the red arrow is the x-axis horizontally, left and right. The z-axis, the blue arrow, that's the depth, backwards and forwards. and then the Y, which is the green arrow going upwards and downwards. So imagine that we want to have a jump pad and we want to launch our ball into the air just going straight up. Well, that would be the green arrow, that would be the y-axis going upwards. So if I was to use this variable here to say, well, if we was to go into this force zone and launch our ball upwards, let's add a value of, let's say, 200, and that will launch our ball by adding force to its rigid body. But for now, we haven't added a code to do that just yet. We've just added a script that has a value on. So in order to do that, we can do two different things. That we can see how close we are to this and then apply that force to the ball, or a more interesting way that allows you to come up with some really interesting levels is to create in a modular way where you can create as many of these zones as you like and then place them wherever you like to create some interesting set pieces or segments for your levels by using colliders and a trigger setting on those. And a trigger just means that the collision will still be detected, but it will not impact the movement or velocity of an object. So if you imagine a car going through an area that has a trigger collider attached to it, that car will be detected, but the car won't have any impact in terms of its velocity or movement. It will just register that it's gone into a certain area. And this is how the force zones are going to work. They're just going to detect our ball has gone into the area, and then it's not going to stop the ball from moving. It's just going to apply additional force onto it. So I'm going to add a box collider to this game object, and you can see this green gizmo here. And that option that I mentioned, trigger, we can see it's a tick box that is currently unticked. We just want to hit that button just to toggle that on, meaning that this is now a trigger, or the collider is now a trigger, and this will allow anything to go through it, but we can still get the detection of intersections with game objects that do have colliders on. So if that's confusing, that's fine. Once you see it in action, it will begin to make sense. But if I was to hit play, just to preview that, we can see I can actually just still go through that area, no problem. But if I was to bring up my scene back here for a second and put that side by side and then untick that option and then try to move now, you can see I can't move any further. It's blocking me because of that shape of that cube. But again, if I was to hit the is trigger option and set that to true, let me just set that again, we can see we can actually go through that now. So it's just a way of still using collision detection, but not necessarily impacting the velocity of an object. So we're going to use this as a way to use launch pads, ramps, any way that you think you may want to launch a ball in any direction or with any force that you think is needed. So what we need to do that. So first of all, we can do what's called a game object tag. So we can know that if we are going through this trigger, we know what the purpose of this trigger is, because we can add many other game objects that function in a similar manner, but we want to make sure that we're reacting in the correct way. So in the case of the force zone, we're applying force to a direction of our choosing. So in order to do that, if we select the force zone and go down to our drop down that mentions tag, we can add our own custom tag. So I'm going to go down here and hit the add tag button. You're going to get a list, so there won't be any custom ones made just yet, but we're going to make our own. And we're going to call this one force. Yeah, let's just call it force. It's easy to type. And if we enter that, and then you'll see that we now have one item on our list. And if we select our game object again and go back to that tag drop down, we can now see that force item we added is now available to select. So I'm just going to hit select, and then we can see that our game object is now tagged with that. So what we can do with that now is every time that our player collides with another collider that may be set to a trigger, we can get a bit more information about that. So if we had one that is, let's say, the finishing line, and we tagged that as the finish, we don't want to apply a force. We perhaps might want to end the level, or we might want to move on to the next section. So it's a way for us to find out what we're colliding with, even if it is a trigger and They have different purposes. We use that as a way of differentiating between the two, or many other options you may choose to have. So what we can do in our player script is use a similar function to what we did with the collision, but for the trigger. So we can say on, capitals, on trigger enter. We can then use that information to then react to it. So what happens with this function, it passes in the information with the other object it collides with, or the other collider it collides with, and then we can get a bit more details about what kind of object it is, or any other parts of information that we're looking for. In this case, we want to find out what tag that collider has. So what we can do is, if we copy this, we can say if other dot GameObject.tag is equals to false, then we can say we can add false to it, because we know that we've collided with a zone that should be adding false. So I'm going to say rigid body RB, the variable that we created at the top here, dot, there we go, dot add false. Now this is the interesting part where we can start to communicate with that script. So on that game object, we have that script called force zone. This holds the value of how much force is going to be added to that ball. So what we want to do is we actually want to get hold of that value once we know that we've collided or intersected with that force zone itself. And we can do that by getting hold of that component and then retrieving that value. So in order to do that, what we want to say is, so again, using the reference to that other collider we intersect with, let me just copy that, and we can type in other.getComponent, and we're going to say force zone, there it is, and now we can access the variable that we created in there called force. So you can see it on that list there. And that's all that we need to do. So it's going to, as a player, if we collide with that area or intersect that area, we're going to first check what the tag is. If the tag is false, that means that we know that we're colliding with or intersecting the area that will begin to add force to the player. But we need to first get that value and retrieve it from the script. So we're getting the component of force zone and then accessing the force value. So it may be a bit confusing, so perhaps rewind this a few times if it doesn't make sense. But if I was to just play that now, it may make sense of how it all fits together. So if I move into the zone here, you can see it's detected that it's the correct tag. 2, it's retrieved its component called force zone, and finally it's applied that value to the player. So it's doing all of those things simultaneously, but the reason why it's useful is because we may have other colliders that are used with other tags, but we may not want to apply force to them. So it's a way of just making sure that we have the correct behavior depending on what we've collided with. So this is quite a bit of the mechanics that we need to create an interesting level, but there's a few more things we can do as well. So the next point that we can do is let's also add a starting point, so you can move around where you may want to start your level, and then also an end point. So let's do that. So in order to do that, let me close this window as well. This is the one I created earlier. Let's do that first. So let's say we want to have a starting point for where your player spawns the ball. So I'm going to create a new game object, and I'm going to call this start. And I'm also going to give this a gizmo icon, so let's change it to orange, and let's just move that to 0, 0, 0. So we're at the very center of the starting tile. So first of all, let's save our player ball. So if you see that your game object for the player is already blue, that just means it's linked to a prefab already. Because we've added our own changes, and we want to perhaps change the ball to make variations for ourselves and make our own ball from that. What we just want to do is let's just go to the prefab and unpack that, and that should remove that blue text. So it shouldn't be blue once you have done that. and then now just drag that into your asset folder down below, and it should become blue again, and you'll see that our ball is now in our project files down below. So I'm just going to remove that for 1 second, and let's go back to our start game object. I'm going to add a very simple script just to spawn in our ball wherever this game object is placed. So again, making it easy for anyone to go ahead and create some really interesting levels, but this is where the ball will start, or your player will start. So I'm going to call this start spawn, and just quickly create that script, and let's just open that as well. And what we want to add is one public game object variable. So it's going to be a public game object, and this is going to be called player. So as soon as what we're going to have, as soon as we start the game, wherever this game object with this gizmo is placed, so you can see I can move it around, wherever it's placed, it's going to spawn a ball, our player's ball, in that position. So once we started the game, we want to say spawn our prefab, the prefab that we created just a moment ago in project file, as you can see below. So in our start function, this happens at the very beginning of our game. We want to just spawn that game object for our player ball. So we can just start typing in instantiate, which just means to create a copy of that game object that we created just a second ago for the player ball, and we want to type in player. Now we want to also say its position, so we can set its position to be where this game object, the one with the orange gizmo, is. So if we just type in transform.position, meaning that it's at the same position that this game object is in, then the final point that we just need to add is the rotation. So for this point, you just want to type in quaternion identity, and in simple terms, that just means to keep its rotation. So it's asking you what, in terms of the whole piece of code here, we're going to instantiate a clone or a copy of the player ball. We're going to link in what that game object is, which is the player ball, and then we're going to set its position, which is going to be where this game object is placed, so the one with the orange gizmo in the screen. And then the final point is just setting its rotation. So as this ball, it doesn't really matter too much, but we're just going to set its rotation to be as it is, so it doesn't need to change. So we don't actually need this update either. So if I was to now link our game object of the player ball into that script, we can see if I can drag and drop it here, and if I move this game object around, we can see once I hit start, it will then begin to spawn in that ball wherever I place that object or game object. So I've moved it a bit to the side for now. Let me move it over here. And you can see wherever I place that game object now, it will then begin to spawn the ball. So it's hitting that zone that we created there earlier, so we probably don't want it to spawn there. So let's just move it over here. There we go. And now you can use this as a way of quickly setting the starting point for your levels. So we still have that false zone that I mentioned earlier. So if we just move forwards, we can see we add that false there. So this is the core mechanics of creating that. So the next point, and this is a point where all of you can now go on and create your levels, is by just selecting what things may be interesting and look at what kind of ideas you can come up with. So you have the toolkit now to begin creating your levels. So I'm just going to move that to the side, the false zone, and let's just have a look at that folder with all of the meshes in there. So let's, as an example, include let's add a tunnel. So let's remove this one for a second. So let's add this tunnel, and perhaps we use that force zone to push our ball very quickly. And I'm going to duplicate that and move that along. And then the next point will be a ramp. So let's have a ramp as well. So let's use this one. So I'm going to move that all the way up there. And I'm just going to have let's say the end point towards the end of this over here, and I'm also just going to rotate that around. Let's just rotate that 180 degrees. There we go. So obviously you guys can spend a bit longer creating a level compared to me, but we have what we need to create some really cool ideas. So coming back to what we mentioned with the full zone before, we can now play around with this and use this how we see fit. So let's say, for example, we move it in this little tunnel. I'm going to shrink it down just a little bit. So I'm going to reduce the collider size by 0.2 and say 0.5, actually 0.2. Let's change those to 0.5. So if our ball goes into contact with this area, perhaps we just use it as a way of pushing it very quickly through the tunnel. So that value on our full zone script no longer will be 200 on the Y, but let's actually put that 200 on the Z. So let's have a quick preview of how that looks. And one thing I forgot to mention, any new tiles that you do add, just make sure you add the mesh collider on them. So that's one thing I forgot to do. So I'm also going to add a mesh collider for all of these pieces. So we've got a mesh collider here. We've got a mesh collider on this one, yep. A mesh collider here. And then finally, this one as well. Just so your ball doesn't fall through and ignore that piece of the level. So if I was to preview that now we can have a little tunnel. We can put our ball through that, and it's been shot forwards, but I think we need to add a bit more force as well. So let's change that to, let's say, 300. And let's just put that side by side so we can see. And if we go forwards, go through the tunnel, we can see our ball got shot through. So this is almost the essentials to begin creating some really interesting levels. So I've only shown a very basic one. So this is where it comes to all of you and to get thinking and think of some really cool ideas for any levels that you create. So one of the best parts about this project now is that you don't have to go back and do any code. It functions as needed, but it's all about placement and your ideas and how you want it to all work together. So an example could be if I want to make the ball go even faster up that ramp, or I could create a copy of that full zone, move it over here, perhaps I'll make that a bit larger, and then let's move it perhaps a little bit, yeah, like here. So perhaps we want to make it go quite fast, so actually perhaps 400 on the Z-axis and then an extra 100 on the Y-axis, so perhaps give it an arcing effect. So now we might actually get our ball on that little island on the opposite side. So again, let's put that side by side for a second. Let's have a look. Oh, I don't know if anyone saw that, but it slightly overshot the island. Let me just play that one more time. So if you see on the right hand side of the screen and track that ball, let me select it so you can see. There we go. If you go forwards, we missed. But yeah, so this is the base template to begin creating some really interesting levels. So it'd be really interesting to see what all of you come up with. This is just something that took a few seconds to do, but you can imagine what you can do with an hour or so, or even longer, by using all of these pieces. So I hope this was interesting. I hope to see what ideas and levels all of you come up with. If you would like to see this expanded upon with additional features, do let us know. But other than that, I hope you all enjoyed, and I hope to see what all of you come up with. Other than that, I hope all of you enjoy the rest of the summer, and hopefully I'll see you soon as well. Take care, and bye-bye.